So thank you very much, Bertrand, for inviting me to give a talk in this Atrass series. So hi everyone, I am Shoaib Ehsan. I'm an associate professor at the University of Southampton, working in the School of Electronics and Computer Science. And today I will be presenting the work that we are currently doing on our recently funded project called PRIV-LOC. So this project is funded by the UK AI Security Institute, and it's about assessing and mitigating the privacy risks of the most sophisticated vision language models that we have now got in the case of image-based geolocalization systems. So the idea is very simple. So where in the world is this photo? So before going to that, I would like to show you the team which is working on this project with me. So I'm the principal investigator of this project, and this project is being co-led by Professor Jack Stilgo, who is a social scientist, and he is currently a professor of science and technology studies at the University College London, and Professor Michael Milford, who is the director of the QUT Center for Robotics, and is a world-leading expert in the domain of localization technology, especially based on vision. And we have got two named researchers, Oliver Grange and Sania Waheed, who are working in this project with me. And the project is supported by a number of partners, BT, BAE Systems, and Privacy International. So, so this project is a multidisciplinary project. It's not a pure technical project. It is a multidisciplinary project because the problem that we are tackling, that is socio-technical in nature. So it's important to address this problem using a multidisciplinary approach, and we want to assess and mitigate the privacy risks of the vision language models that can perform geolocation. So the core challenge is that these most sophisticated AI models that we have got today, they can actually infer your location even if the metadata is basically stripped off from the images. So this is a big challenge, and the goal in this project is to develop some technical and governance solutions that can enable responsible innovation while protecting privacy. Okay, so coming to the next slide. So if you look at this image, so this is a very random image. It can be anywhere in the world. It can be in the US, it can be in Canada, Australia, UK. But when you upload this image to a VLM like GPT-4V, and you ask what is the location of this image. So the interesting thing is, and maybe the scary bit is, that it is actually able to tell you the exact location where this image was captured. So this particular image was in the Snowdonia National Park, Wales, UK. It was captured over there, and GPT-4V was able to answer this question correctly. So let's see another example. So this is again an image from one of my colleagues who went for a holiday, and this is the image that he captured over there. And this image was stripped of all the metadata, and it was sorry, sorry, is there any question?
I think one microphone was active and I'm deactivating it.
Okay, no problem. Okay, yeah. So this is one of the images which was taken by one of my colleagues during a holiday, and we uploaded this image to again GPT-4V after stripping of all the metadata, and the GPT-4V was able to locate that image quite accurately, that it was taken in the Lake District National Park in Cumbria, UK. So these are the capabilities of current vision language models. And now, the first thing which comes to mind is this image-based geolocation. That is not a new thing. So it has been research for the last 15-20 years at least, and there has been a lot of approaches where people have tried, mostly computer vision based approaches, where people have tried to find the geolocation of an image using different methods, and it has got a number of potential benefits. It can be used in disaster response and mapping, and it is very widely used in robotics as well. Suppose if you have there is a very important problem in robotics called the kidnapped robot problem, where you put the robot anywhere in the world and it has to find out where it is. So this image-based geolocalization that has been going on for the last 15-20 years at least. So what's the problem if the vision language model is actually able to provide you with a location estimate? So the problem is that these vision language models, they are now being integrated into even the social media feeds. For example, the Llama model is now integrated in the Facebook feed. So all the photos that you are sharing on the social media platforms, even if you say that you don't want your geolocation to be shared, even then, without any metadata, these images can be used to provide your location estimate quite accurately. So this is one of the big problems, and it's not just that, it's that these vision language models are being deployed at scale in our society. So this is the big issue that we are facing. So it's different from what we have been doing for the last 15-20 years, trying to solve the image-based geolocalization problem for one specific sector. For example, in the case of robotics, so it's very important, and for a robot to know its location accurately. But when you see these current VLMs, and they are able to accurately geolocate on the basis of the images, and they are being deployed at a very wide scale in our society, and being integrated into the social media platforms. So it basically raises a number of potential issues, and there can be things like stalking, discrimination, threats to critical infrastructure, there can be mass surveillance or targeted attacks. So this is the issue that the society is facing at the moment. So this slide basically provided you with the context about this project. So the other thing is that these vision language models, they are these vision language models, they are being deployed, but we don't know much about these systems. We don't know how, the other vision-based localization systems, for example, which are used in robotics. So we know that in the case of changes in light, viewpoint, seasonal changes, weather changes, so there is a significant degradation of performance of localization systems when we see all these variations. But at the moment, because there has not been much research in this domain, so we don't know what the VLMs are going to do with in the case of these lighting changes, viewpoint changes. So we know that these VLMs are trained on a large number of images, internet scale data, but our hypothesis is that they will have similar kind of failure modes like the other vision-based localization systems, but it still needs to be investigated what happens when all these variations in lighting, viewpoint, and seasonal and weather changes occur, which are different from the training data for these systems. So if you look at the GPT-4V system card, which was released by OpenAI, so it says that the model's geolocation abilities generally do not go deeper than the level of identifying a city from an image in most cases, reducing the likelihood of being able to find someone's precise location via the model alone. Now, this is the system card which OpenAI has released, but the problem is that, is it true? Do we know that how the VLMs will perform on different types of images, on social media type images, on Google Street View type images? What are the privacy risks beyond what the system card mentions? And then how consistent are these explanations and predictions? So if you ask the same question to the VLM, let's say 100 times, will it be providing the same answer, or will it be telling you something else? So there are consistency issues as well, which need to be investigated. So all these issues require systematic evaluation and to assess the actual geolocalization capabilities of these VLMs. So this PRIV-LOC project, which is funded by the UK AI Security Institute, it aims to evaluate these geolocalization capabilities and risk of the vision language models. And we also have got a work package where we are analyzing the potential misuse scenarios and societal concerns. And there is a work package which is basically focused on building some mitigation strategies, both technical and governance, so that we can somehow lessen the privacy risks that we see now. And we would also like to propose some governance frameworks. So the first work package in this case is the technology assessment work package. And here we did a large scale evaluation to assess the geolocalization capabilities of the vision language models. And let's move to the next slide. So we did this large scale study, and this was written in the form of a paper for AAAI Fall Symposium series, and it's going to be presented over there in November 2025. And this paper is currently available on Archive, which is assessing the geolocation capabilities, limitations, and societal risks of generative vision language models. And we used a very simple kind of approach for assessing the capabilities of these vision language models. So our approach was that we took a fixed prompt asking the model about the location of that image and providing a location in the form of geocoordinates. And we took different geolocation query datasets. In this particular case, we used 4 datasets: IM to GPS, IM to GPS 3K, and then there was this GPT chart geo dataset and OSV dataset, so we use 4 standard datasets which are used for image geolocalization tasks. And these were provided to a black box VLM. So we use the VLM in a black box setting. And the main reason for that was that if the problem that we are tackling and what we find interesting is that because these models are being integrated into the social media platforms. So if there is a user who is uploading those images to those social media platforms, so they won't have any control on the VLM which is being deployed on the other end. So that's why we did this evaluation in a black box setting where we don't have any access to the internal representations or to the model weights, nothing. So we basically tested these models in a black box setting, and then the VLM produced geocoordinates in the form of latitude and longitude. And then we had this ground truth, which we used to calculate the distance between the produced geocoordinates and the actual coordinate for that particular image. So we utilize this distance to calculate the accuracy of the prediction. Okay, so this is the GPT GeoChat data set results that we have got. So this is the leaderboard. So we basically evaluated 25 different vision language models. And as you can see, so GPT 4.1, so that has got an accuracy of 61% on the GPT GeoChat dataset. And on the x-axis, you see recall at 1 kilometer percentage. This shows that the number of predictions that this VLM has made for all the query images. So 61% of those predictions were within 1 kilometer distance of the actual location. So it's getting 61% accuracy on this GPT GeoChat dataset by a VLM, which actually doesn't have any map. So it's quite it's basically very surprising that it has managed to get this kind of accuracy on a data set. But there are things which need to be considered here. So there is a chance that the VLM has already seen these images in the training data set. And the other thing is that this GPT GeoChat data set that has got images which are social media type images. So again, there may be some bias in training as well. And so these are more detailed results for our study, where we have got all the 25 vision language models that we have used, and it shows the geolocation recall at kilometer accuracy on this GPT GeoChat dataset. And as you can see that as you increase the error threshold, so from 1 kilometer to say 5 kilometer and 10 kilometer and up to say 750 kilometers, so the accuracy of if you introduce this threshold, then the location estimate that you can get will be more accurate. So there is this categorical accuracy as well. So this is based on the administrative area. So on the basis of city and country. So we also did this evaluation on the IM2 GPS 3K dataset, and the VLM had to predict which country it is and which city it is, and it's really you can say that it shows amazing performance. So GPT-03 that has got the highest accuracy on the city level scale and on the country level scale, and then there are other models as well which are performing well. So the main takeaway is that these vision language models, they are able to predict the location at very accurately, and but there are some failure rates as well. So here we are showing the failure rates. So by failure rates, we mean that when we ask the vision language model to produce the geocoordinates for the input image, so either it said that it cannot produce the result, or it simply declined that command. So here are the failure rates for different models, and the open source model IDFix that has got the highest model reliability issue, which is around 70%. So what are the main takeaways from this study? So let's talk about that. So as I've said, we utilize 4 different data sets. So if we look at the OSV data set, which is more which has got images which are more like Google Street View images, and then there is this GPT GeoChat dataset which has got images which are social media type images. So if you look at The results for these two, so there you can see a performance asymmetry. Um, we can see that the performance of the different vision language models is much better on the GPT GeoChat dataset, which is social media, which contains social media type images. But on the other hand, the performance is quite low on images, which are Google Street View type images in urban settings. So the the main takeaways from the study is that there is performance asymmetry, and there may be some training data bias as well. That it's basically due to the data set which was used for training these VLMs, which and that's the reason they are able to accurately geolocate those social media type images rather than the Google Street View type images. So this basically has impact on the use cases. So it at the moment it seems that it's not very suitable for disaster response or urban planning or environmental monitoring. But there are privacy risks because the social media type images which people upload to these platforms, it shows that these sophisticated AI models are able to accurately geolocate those images. So after this study, we thought about extending this evaluation framework more. So what we did was, so in the first case, the work that I have described, which is to be presented at this AAAI Fall Symposium series. So we created two other scenarios, and the scenario two that you can see on the screen. So what we said was that they can, if we have semantically equivalent prompts and the same query data set, so then what will be the output of the VLM? So it means that, let's say if I ask the VLM to this question that where is this location on an image? So it will produce some geocoordinates. And again, if I ask the same question, which is semantically equivalent, but in different words, like, what is this location? Provide me with the geocoordinates. Then these are semantically equivalent prompts, and the answer should be the same. But does the VLM actually provide us with the same answer in the form of geocoordinates? That's what we tried to test. And if you look at the scenario 3, which is shown here, what we tried to do was that we kept the prompt fixed, but we took semantically equivalent images. So by semantically equivalent images, I mean that if we have an image which was taken in the morning, and we have the image of the same scene which is taken in the evening. Now these are semantically equivalent images, but they have got these lighting changes because one was taken in the morning, the other one was taken in the evening. So we also wanted to see what is the effect of these light changes or viewpoint changes in the case of VLMs. So again, we try to see the accuracy of the VLMs, and we also wanted to investigate the consistency that if the same same prompt is given to the VLM, let's say 100 times, then how many times it basically provides with the same response. So for this particular study, we used the 4 data sets, IM to GPS, Tokyo 24/7. So these 2 data sets are normally used in image-based localization papers, and Tokyo 24/7, it has got light changes. So some images were taken in the morning, in the afternoon, at night. And then we also added another type of testing where we thought that to test if let's say if these images are already seen by the VLM in during their training. So if we capture our own data set, which is a private data set, and we do the same testing in scenario 2 and 3, then what will be the results? So we captured two data sets, CSN and LZR, which were captured in Italy and under different lighting conditions. So we applied these 5 prompts. What is this location? Give me the geo coordinates only. Where is this place on Earth? Can you predict the geo coordinates? So we had these 5 different variations of the same question, and then we applied that to different VLMs. So here is the example for GPT-4V, where we provided these in scenario 2, we provided these 5 prompts, and we gave the same image. We gave the same image for all 5 prompts, and then checked what we have got in the form of geocoordinates from the VLMs. And in the case of scenario 3, we had these semantically equivalent images given with a fixed prompt, and we got all those results in the form of geocoordinates. So these are the results that we got for scenario 2. So we tried to test the consistency. So if the same prompt is given, which is semantically equivalent, then how many times it basically the VLM returns the same answer, whether that answer is correct or not. So that is a different thing, but is it consistent or not? So these are the results that we see, that when we have this error of 1 kilometer, you can see that the consistency is quite low for some of the models. But as you increase the error threshold, then the results become more accurate, more consistent. And these are the results that we have got for scenario 3, where we had semantically equivalent images. So under different light conditions for the Tokyo data sets and our 2 private data sets, CSN and LZR. And on IM2 GPS, and again, the 2 main conclusions that you draw from these is that, yes, there is definitely performance degradation when there are changes in light. So you can see that the performance degrades under different lighting conditions. And the other thing which is quite noticeable is that for the private data sets that we captured ourselves, the performance goes really down. So it was unable to even predict one image for the case of when we had this error threshold of 1 kilometer. So this basically again shows that in the case of Google Street View type images, these VLMs do not perform well. Okay, then we are also investigating what are the different cues that these VLMs use for making a decision, because this is this needs to be investigated to understand which visual features do they use. So the strategy that we used was that we actually asked the VLM to tell us why do they think that this is this location. So this is the word cloud that we got when we have generated this word cloud based on the rationale provided by the VLM for estimating those locations. And you can see that architectural style that is very important when these VLMs are making decisions. And then there are things like historical sites, large population, famous landmark, and things like that. So we are currently working on that, and we need to validate and test the consistency of these explanations, because these are only self-reported cues, and they may or may not reflect the actual decision process. So we are currently working on that as well. Then this is a game that we have actually produced for this PRIV-LOC project to investigate how the humans actually compare with the AI models that we have now got for image-based geolocalization. So this is inspired by the GeoGuessr game. So I am going to run this game. Can you see my screen now, Bertrand?
Yes,
Can you
yes.
can you see the game screen?
We see the presentation only.
Okay, you are seeing the presentation only. Let me
I think you have to change. You have to share another window.
Yeah, that's what I'm going to do now. Can you see my screen now?
Well, we see, we see a web page.
Yeah, so it says PRIV-LOC Geolocation Privacy Challenge.
Yeah.
Yeah, great. So this is the GeoGuessr inspired game that we have produced, and it's freely available. So I'll show you the demo for this. So this is an image which is presented, and you have to guess the location of this image. So let's say I say that this is the location of this image, and then I select yes. So it will basically tell us that, okay, I selected this location, but actually this is the location where this image was taken. So we take this, the challenge, we select the next one, we again select this. Let's say this one is somewhere here. We select the location, and it tells us, no, this is not here, but the actual image was taken here. And select this. And finally, let's suppose we select this. So at the end, so this is what we get. So it basically ranks. So the same images were provided to GPT 4.1, and its score was 4,700. And for with GPT 4.0, the score was 4,600. And I am the last one here. So these it gives you a leaderboard that when these particular images, the 5 images where I have done the geolocation, when these were presented to these AI models, how did they fare? So you all can access this game and try to see how good are your geolocalization capabilities. Okay, I'm going back to the presentation now. Okay. Can you see my screen?
Yeah, but it's not in presentation mode.
Yeah, let me go back to that.
Yeah, but okay, but we are back at the beginning.
Yeah, I'll go back. So let's move forward. Okay. So this was the work that we have done related to the assessment of the geolocalization capabilities of the vision language models. We are still working on that, and I will now quickly tell you about the second work package, which was about risk analysis. So we had a stakeholder workshop where we had people from different sectors, and they basically raised some of the issues related to these geolocalization capabilities of the vision language models. And so there were people from, for example, um, some Bellingcat, which is an organization which is being run by the journalists. They have this concern that if an image is taken by a journalist, then that image can be utilized for finding the geolocation of that particular person. And similarly, we had people from BBC, and they had similar sort of concerns. So, we are in the process of writing a report related to that, and they also had these concerns that if these vision language models, they are able to they are able to tell your location with pinpoint accuracy, then when you combine these with the search engines, then maybe it will improve the performance further. And then there is this rhetoric as well that this capability that is mostly just dangerous rather than helpful. So this is again open to debate. And currently we are working on this final work package, which is about the mitigation strategies, and we are working on some technical solutions. How can we reduce these risks? Because the problem in this case is that we don't have control. These We don't have any control on these vision language models. They are being deployed by the big tech companies. So there's one solution that those big tech companies are regulated, and they are not allowed to do this geolocation. This can be one of the solutions, or there can be a solution which is implemented on their side, which does not allow them to infer the accurate location for that image. But we are more inclined towards a solution which can be deployed by the user on his or her own side. So, for example, if we can come up with a solution where before uploading an image to the social media platform, if it goes through a layer in between, and that particular layer or a model tells the user that this particular image has got, let's say, a chance, 50% chance of being localized accurately. So do you want to upload this to the social media platform or not? So I think this type of solution will be really helpful. At least it will uh, create an awareness. It will create an awareness which is currently missing, because there are many people who do not actually know that. So they think that because they have not given any consent to share their location data, so the social media platform won't be able to get that location. But actually, because of these vision language models, which are now being integrated into the social media feed, so it is actually possible to get the location accurately. So we are currently working on these technical solutions, and hopefully by the end of this project, in the next few months, we should be able to come up with some practical solution for that. So with that, I think I would like to play this video that we have got this for the PRIV-LOC project, and then I would like to thank you for listening to the presentation, and if you want to ask any questions.
Thank you, Shoaib. Very interesting. Yeah, just I believe that the music of this movie was generated by AI, right?
Yeah, you're right.
So it's not real music. So somehow, I see at least one question on the chat, and I had the same, in fact. So we will discuss that. But first, I would like to say two things. My first remark, is that usually when we look at leaderboards,
Yeah.
For AI systems, we try to prefer the best ones. But in your case, I think we don't prefer the best ones. We are preferring the ones which are worst.
No, not really. If you look at so if you look at this leaderboard, so the top one is GPT 4.1.
Yes, so it's the most dangerous one. It's the one that is able to break your privacy.
Yeah, it's the one. Yes, you're right in that sense. So if you look from the privacy perspective,
I prefer the last one, where ATB or whatever
yeah,
it is.
Yeah, yeah, you're absolutely right. From a privacy perspective, GPT 4.1, and that is the most dangerous one, as you have said.
You also made a remark about the sincerity the truthfulness of explanation that you got from the LLMs. And it appears that yesterday we had a conference in Paris where a Danish researcher was showing what she obtained in looking for the truthworthiness of explanations in LLMs. And she, in many cases, in fact, they don't give the reasons, they give whatever they think they should give, but the real reasons, the real factor are not shown in the answer. So you have to be effectively cautious about this picture.
Exactly.
I agree. Yes.
Yeah, exactly.
So there is one question.
Yes, please.
There is at least one question. Maybe, I see also another hand raised. But first, and I'm not sure about the answer. I was wondering the same, but maybe I don't know if you know. If this is a violation of privacy, so is this forbidden by the AI Act? Maybe you don't know that, being outside of the European Union.
Well, frankly speaking, I don't know, but I think that it will be a violation of the EU AI Act. I need to check, but I think you are in a better position to tell about that, being in the EU.
Sorry, Bertrand, I am your student in Central Supélec, so I address this question to you, Bertrand. Since we have seen the risk levels of AI Act, and as explained, it's with high risk. So is it something which is controlled at least in Europe by the AI Act or not? That's my question. Or maybe we could discuss that maybe later, Bertrand, as I am your student.
Let's discuss that later. But if there's a lawyer around this virtual table, it would be useful to have his or her opinion about if the AI Act authorizes that. Adrien, maybe you want to answer, Adrien?
Just an opinion, because I'm not a lawyer really, but I've studied a little bit the AI Act and how it applies. And at the moment, the risk level is determined by the use case mostly. So that depends really on the application. But the models themselves, they can enable mass surveillance applications, which are not only high risk, they are completely prohibited. So it depends how you use it.
Yeah, would you consider that this is a mass surveillance? Yeah, it could be in a mass surveillance application. Anyway, it would not even be considered because this application is forbidden, as you said.
Yeah.
Yeah. That's
now we would have to see if in one of the high risk areas there might be consequences such as this one. For example, I don't know. You have to look. I think that there was a first question by Leila, and then we give the floor to Suyan Sai. Leila Mahmoud. So maybe I can just read the question. Are there any practical solutions for mitigation that are considered by an ethical? I'm not sure if I understand what is written. Are there any practical solutions for mitigation that considered by an ethical guidelines, either by UK or EU? So anyway, I think it relates the mitigation solutions with the ethics questions.
Yeah, so as I've said, as far as we know, so this is a very new area, a very new thing, and there are no existing practical solutions for that. And this is what we are trying to do in this work package 3 of our project. So trying to build some practical solution which can be utilized for reducing the privacy risk. So it won't be a perfect solution, but at least even if it can alert the user about the risks involved in uploading that particular image to a social media platform, so that will be really useful. And there can be different things which can be done in this regard. So we are currently working on that.
Yeah, I see a hand raised by Suyansai Ganamanini.
Yeah.
Yeah.
Thank you for the interesting talk. I was thinking about the point that Bertrand raised first with the leaderboard. So I agree with Bertrand that this is the case where you would want a model from the bottom. But if you look at it from a performance perspective, if you had a y-axis of or another axis where you had the performance of the models as well, do you think the bottom half of the models are actually just less performant, and that's why they are bad at recalling where the location is? So is this also a metric for performance itself? Like, is there a correlation between that?
Well, again, it all depends upon the application. So if let me go back to that figure. So if you want to use this kind of AI system for geolocating for, let's say, robots, then you would definitely prefer GPT 4.1 because robotics is the kind of application where you need accurate location so that the robot can perform that task accurately. The problem is that there are so many applications where you actually do not need accurate not need to share your accurate location. And so depending upon your context, so whether you want a system for your particular application which is able to geolocate accurately, or whether you want to utilize a VLM which is not able to do geolocation accurately. So it all depends upon the context. It all depends upon the application. But the problem again is that these platforms, these VLMs, are being deployed not on our end, but on the side of these big tech companies. So we absolutely have no control whether they are utilizing GPT 4.1 on their side for inferring your location, or whether they are using Claude or Gemini. So it's not under our control. What we can do as users on our end is how can we make sure that the model at the other end is not able to accurately geolocate your image. And interestingly, this is actually opposite to what I have been doing for the last 10 years. So I've been working on this vision-based localization and mapping for robotics for the last 10 years or so. And the goal has been to improve the localization accuracy. But in this project, we actually want to do the opposite.
Yeah. So thank you. I think it's time to conclude. So I think if people want to play the game, they will be able to get the URL from the recording. I'm going to stop the recording. The recording will be published on the YouTube channel and also accessible from the Atrass webpage. So if they want to look at it, to play the game, they just can get the URL from the recording. I think I will play the game myself. And if you really like this talk so much that you want to hear it again, for real, come to the iTrack Symposium in Arlington, 6 to 8 November. The talk is on, I think it's on 7th November afternoon or morning afternoon. I'm not so sure anymore. So if you want to hear it second time in physical presence, that's the location. And you will be able to detect that you are there. Thank you very much, Shoaib. That was an entertaining talk.